Well, but bright ideas might have some bottlenecks, and one of the bottlenecks is that if the circuit is a kind of not composed from inductors, but for example holes, conductors, something which you have to solve by field simulation, then you have to accept that any solution would be somehow corrupted by errors, numerical errors. And therefore, in fact, you do not know those points exactly. Those errors would then produce errors in the estimation of zeros and poles. Moreover, it might easily happen that you would never get an exact match due to the errors. So what you have to do is to have some measure and say, well, okay, those two numbers are not really equal, but they are similar. So you would have some threshold on what is equal. A small error means that we would attribute that to numerical errors, and we would treat our model with some number of brackets in the numerator and some number in the denominator, with some known poles and some known zeros, talking in the language of electric circuits. We would find that final and equivalent to what we have been analyzing. But this difference might be also caused by a difference in the circuit itself. Well, let me show, for example, imagine that we have, for example, a resonator. If you have a microstrip line and you put there a small piece of dielectrics, it could be coupled this way, and the resonator made of a small cylinder of dielectrics, this is something that is really used. This resonator could have a high quality factor. That might be possibly thousands, even tens of thousands. Now, if you do not place it very close to the line, the coupling would be weak. And the result would be that, in fact, if you plot a characteristic of transmission, the line has a unity transmission, and at the frequency of resonator, there would be, in fact, just a very narrow slit taken out. At the resonant frequency, the coupling would make the resonator coupled to the line, and the energy coupled to the resonator would increase and increase as far as it is equivalent to losses in the resonator. And although the losses are very low, there would be a very sharp notch in the transfer function. Now, if we use the same technology and analyze this in a wide frequency band, we might, for example, start the analysis here and get this, start the analysis at the end, get this transmission, start the analysis over here, we will get this transmission, and they will be completely in accordance. So the algorithm would stop and plot a nice transfer function, which is believable because it really belongs to some circuit. Unfortunately, it is not the circuit you had wanted to analyze. This is somehow a problem because some of the software packages decide which frequencies you want to use. They make the analysis and don't let you in to stop it. It's like your mobile phone camera. It always knows the exposition, it always knows the focus length, it always knows what you want it to photograph. Unfortunately, sometimes you are so crazy that you do not obey the rules that are in your mobile phone, and you think that the photograph is not good. But the important point is that you have to be careful, because most of software packages save time, and they have a kind of improving the diagrams you got. I remember some times ago we went for a trip to United States, and my wife forgot her camera at home, so we bought the first camera at Tesco. There were foods and anything, but also cameras. So we bought one, and only after some time we noticed that the camera has inside built in a lot of functions that are making any face nicer, which means that they have been making the face more round, they have been making smaller mouth, they have been making whiter teeth, and that's automatically run on each photograph. Fortunately, we did not intend to make photos of people but of nature, and at that point that was not a problem. But with this artificial intelligence you got very nice photographs, and unfortunately from the scientific point of view they were not correct. So the same is applied in most of softwares to have nice plots, and you should be aware of that. And that's what I wanted to tell you today. You should be cautious, and you should check whether the results that are produced by any software are reality, or whether those results are improved to be very nice. Well, and that was what I forgot to tell you last week. I'm sorry for that. And at the time I have finished all what I wanted to tell you within this course, and now we can switch just to discuss examination, which I have already described last week, and other topics. So in fact, at the moment I would change this lecture into a consultation. If you have any questions, please, your questions now. I will just stop the camera because the recording of the lecture is done.